Welcome to Binding Native Plugins with Flutter and Dart. My name is Jeff Ward. I'm a senior software. Can I get slides? Yay! I'm a senior software engineer at Datadog working on RUM SDKs. Specifically, I created and maintain the Flutter SDK for Datadog. So if you're using the Flutter SDK for Datadog, that's mostly my work. Today we're going to be talking about plugin development. And plugin development for Dart and Flutter is all about working with native libraries. It's about working with either C libraries or Swift libraries or Java libraries that exist on the native platform. But why do we want to do this? Well, the Flutter package ecosystem is great, but at some point you're going to run into some stuff that Pub doesn't support, that no one has created the bindings for yet. So you might have to do that yourself. But on top of that, new libraries are coming out all of the time. And all sorts of different companies are coming out with new things, and sometimes Flutter isn't their main priority. For a long time, Datadog didn't have a Flutter plugin, and their community maintained one because it wasn't necessarily a priority for them until Flutter got a little bit of traction. So you would have to do that yourself. And then lastly, you might want to work with some C libraries that work on iOS and Android, but don't really have bindings because they're not popular enough, or they just haven't come out for Flutter yet. And so you might need to do that. So how do we do this? So how are we going to interact with native plugins? Well, in the beginning, all we had was method channels. I promise this is the only piece of AI art in this entire presentation. I do love this piece of AI art, specifically the dinosaur in the bottom that is also a projector. It's great. Anyway, so all we had was method channels. And method channels, if you're not aware, how you use them is in Dart, you create an object called a method channel, which has a name. And then you're going to invoke method on that with a method name. And you're going to give it a list of arguments. Usually you do this in a map, but in reality, arguments are dynamic. You can give it anything. On the Android side, you're going to do the same thing. When you're in your activity, when you're asked to configure the Flutter engine, you will create a method channel, give it the same name, and you'll give it a callback handler that will be called anytime someone in Flutter says invoke method. You then switch on the method name, do your processing, and return a result, and return your result. iOS, again, it's the same thing. In this case, again, in the app delegate, we're creating a method channel, giving it the same name, passing in the binary messenger that we get from the view controller, and we set a method call handler. In this case, we're using a closure instead of a method. But we're doing the same thing. We're switching on the method, trying to find the right one, returning processing, and returning the result. To show kind of how method channels work and the fact that method channels get a really bad rap for being slow, we're going to use a ridiculous example for what method channels can do. So what we're going to do is we've taken the entire Rick and Morty characters API response. This is every character that appears in Rick and Morty. And we are going to serialize it to JSON and send it over a method channel. This is 410K of data being sent over a method channel. You would not do this in real life. If you're sending this much data over a method channel, please find another way to do this. But in reality, so we'll look at the application here, actually. This is just literally sending lots and lots of data over the method channel, 400K of data. And this is on my Pixel 9, but our performance on iPhone 12, Galaxy A31, you'll notice that the actual call time, the amount of time it actually spends serializing that data in order to send it down to the method channel, isn't a ton, especially on the iPhone 12. And if you can see on the my Pixel 9, it's like a millisecond and a half. But the other thing you're going to notice on the far right-hand side in the average is the full response time. The amount of time to get there and back is quite high. You're not spending a lot of CPU time executing a method channel. What you're doing is you have to wait for that async processing to happen. Even with the new changes that have happened in Flutter 3.32 that merged the UI thread and the main thread, you still have to wait for the async message bus to process through. And this can be where you get some of that slowdown with method channels. So what are the advantages of method channels? Well, the benefits are, for me personally, I find method channels are a really easy way to abstract to a single platform interface. Everything is going to be, a name of a method and the arguments that are going to send. As long as you're conforming to that contract, it's very easy to create that abstraction. The other nice thing is that method channels will serialize and deserialize almost any simple Dart type, and that includes all the type data types. Float32 list, Float64 list, all of those. And they're great when timing isn't an issue. When I need to kind of fire and forget something and I don't need that response in real time, method channels are a very, very nice way to do that. What are the drawbacks? Well, method channels are inherently asynchronous. Again, even with the changes in Dart 332, or in Flutter 332, you're still waiting for that asynchronous loop to happen. And these thread thunks, this async await, can harm perceived performance. Again, your CPU is not spending a lot more time, but it feels like it is because you're waiting for that async await call. Writing native binding code with assumed contracts. So when you write all of this code, you're kind of doing stringly typed programming. You're saying, this is the name of my method as a string. All of the arguments you're doing are usually string to dynamic pairs. And so you have to assume all these contracts. And so I usually unit test the contracts in all cases. Or if you don't want to try to do that, you can rely on code generators like Pigeon, which will do a lot of that stuff for you. But the last disadvantage is Flutter is kind of looking to encourage more packages to move away from this and drop them in favor of the FFI equivalents. This is a quote from Miriam, who's a product manager at, on Flutter. The fundamental challenge with method channels is that they can be time-consuming to implement and maintain. And this is in her post about the path towards more seamless interop. Flutter and Dart really want you to move away from method channels if you can. So what does the new native communication look like? Well, we have FFI Gen and FFI Gen. This is how you're going to interact with C and Objective-C for iOS and other C libraries. And now we have J and I Gen for Java and Kotlin. And like Swift is in there somewhere. We don't know what's going on there right now. Right now, there is a thing in the FFI GitHub for Swift specifically, but it hasn't had much happen with it. Right now, if you want to do Swift, you have to create an Objective-C header and then bind it that way. But Swift and Kotlin FFI generation are still experimental. There is an early access program that, again, Miriam posted about as part of Google I/O. If you want to sign up for that early access program and like give the feedback to the Flutter and Dart communities about how this works, go ahead and go join that. So let's, instead of working with a ridiculous example, let's do a more practical example. We're going to use OpenCV, which is Open Computer Vision, to detect Arucos. These are very small QR codes that are meant for be able to detect very quickly, and they're meant for AR applications. We're going to use a static image in this case so that we can control how much time it's taking in order to send that image back and forth. But what we're going to do is we're going to actually time them using method channels. We're going to time J and I Gen on Android, and we're going to use FFI Gen to create a C wrapper, which we're going to test on both iOS and Android. One of the nice things is OpenCV is a C library, and thus we can use that for that. We're going to time the invoke method call. We're going to time the amount of time that OpenCV uses to classify the image, and then we're going to time total response time. Oh, and by the way, all of the source for this is available up on my GitHub. So if you want to verify all of my findings or tell me how much of an idiot I was for binding stuff this way, please go ahead and open issues. Yeah, so this is what we're going to do. This is method channels using OpenCV. This image is going to be sent down the method channel, and it's going to respond with the locations of all of the Arucos in that image. That's what it does. We also did the same thing for C. This is all being run on Android, my Pixel 9 Android, by the way. And we're going to do the same thing with J and I, right? And so what does our timing look like for that? Oh, a few caveats. This was added late. We're doing all of this, by the way, the hard way. If you didn't see Simon's talk earlier about using native assets for cross-platform FFI, definitely go watch that as well. That's some of the newer ways to do stuff with some of the newer plugins. But we're not going to use any of that. We're going to do everything the very difficult way. So how do we do this? FFI Gen. First thing you need to do for FFI Gen is you need to add FFI to your dependencies and add FFI Gen to your dev dependencies. Then you create an FFI Gen YAML. You can do this in your pub spec, but I actually recommend against it, especially if you want to bind multiple C libraries. Having a separate FFI Gen for each library is preferable. And then you run FFI Gen, Dart run FFI Gen, you pass it your config, and it drops out this giant Dart file that will communicate with the header file that you're given. So here's the example. For OpenCV, we're going to include everything all of its header files. But we're also, the other thing, we're going to include the OpenCV wrapper that I'm working with. But we're also going to mark everything as leaf. What this means in Dart with FFI Gen is all of these functions are guaranteed to never call back into Dart. There are situations where you can't call certain functions in FFI unless you can guarantee that they're leaf functions. So if you know, as with OpenCV, that I'm never issuing a callback back into Dart, you can mark them all as isLeaf. There's a performance benefit to doing this, and you can use it in more circumstances, so make sure you mark them. Again, everything in OpenCV is this way, so I can safely do the all.star. Here's some example FFI code. As Simon had pointed out, you need to load your library before you start using it, using dynamic library open. For Android, we're using a .so file and loading that OpenCV wrapper first. But in iOS, we actually statically linked OpenCV. So as a result, we're just going to load up in the executable. We create the OpenCV object that was generated for us by FFI Gen, and from there, we can just call functions on that. So here's an example of calling that function. One of the first things to point out is this using arena. So when you're allocating objects or pointers to pass down to FFI, you are actually allocating memory and you need to delete it. And instead of having to remember to do that, FFI gives you this nice thing called an arena, where if you allocate out of that arena, it will automatically deallocate all of the memory you allocated it for at the end of the block. If you've ever used a using statement in C#, that's this. Once you've allocated, so here we're actually allocating out of the arena. We're allocating a buffer of data that we can then copy the image into, assigning that to a mat, which is an OpenCV thing, and then calling the decode. You also notice at the bottom here, because I'm allocating some memory in C, I have to free it as well using the free decode result. This was not allocated by Dart, and therefore the arena won't get rid of it. JNI Gen. This is very similar. It's going to look very similar. You need to add JNI to your dependencies. You need to add JNI Gen to your dev dependencies. You need to create a JNI Gen YAML. Once again, you can do this in your pub spec, but if you're binding multiple libraries, it's better to have it separate. New step, you need to build your APK. JNI Gen is actually going to reach into your built Java code to get all of the information out. If you don't do this, you get a very weird error that at the very top of the error tells you that you forgot to build your APK, followed by a whole bunch of red text that's very hard to parse. You have to scroll all the way back up to the top to figure it out. You only really make this mistake once, then you're like, oh, it's that error again. But I've saved you the difficulty. And then you run JNI Gen, Dart run JNI Gen, pass it the config. This is what a JNI Gen YAML looks like. You're going to pass it the source path. In this case, you're passing it the path to your Android application, which will then be built. And then you pass it all the classes that you want to generate for. You can use wildcards here if you want to. You can generate code for entire packages. But in this case, I've listed out everything I want to generate manually. JNI Gen example code. This is going to look very similar. So you would think that with a garbage collector, you don't have to worry about memory, but you'd be wrong. You actually are going to create an arena. Rude. And the reason we're going to create an arena is because for all of the JNI objects that are being created, you need to release them manually, right? The finalizer will actually do this for you. It will call release, but if you're creating a lot of these things like really fast, you're going to have to wait for both the Flutter garbage collector to get rid of them, and then you have to wait a little extra time for the JNI garbage collector to get rid of them. So it's better if you release them manually. So one of the things you'll see is I'll use the arena, and then you'll see these released by scattered throughout the code. This is saying, hey, when this arena closes, release all of these objects for me because I don't need them. And then the other thing to note with JNI Gen in particular is Dart doesn't support overloaded function names, and so any overloaded function name has to be done through $1. So these are multiple different function names that take different types, and therefore you just have to look manually and figure out what are the correct types that I want to pass to this function and see which one. Is it $1? Is it $2? Is it $3? Oh, $1 is the right one. So here's the performance. On iOS for method channels, you'll notice the classify times are going to be very, very, very similar in terms of averages. So 3.36, 3.23, that's the amount of time that we're spending in C. And you'll notice the response time is much, much, much faster using FFI, but not that much faster. There's like a millisecond difference between the two. But there's definitely a little bit of that overhead. On Android, we get a little bit worse. Most of this timing was done pre-332, but I tested and it's the same in 332. You'll notice that, I think it's because Java just takes a little bit longer to get through that asynchronous queue. So you get a much larger gap on the method channel one. So the classify times, again, are basically all the same, but we get a much faster full response time out of FFI and Gen iGen. And we get a much faster response time out of FFI Gen versus using the C library directly rather than going to Java and then into C for OpenCV. So, benefits of FFI and JNI. They tend to be faster, although your mileage may vary depending on how much you need to serialize and deserialize your individual objects. You can get synchronous response, something that you are unable to do with method channels. What are the drawbacks? Some Dart objects don't translate real well to C. You have to, in the case of the image, I had to pull out the byte data, write it to a U8 list, and then with allocated memory and write that down to C. And this is true of a lot of different Dart constructs. They just don't lend themselves well to C or Java. For complicated objects, you might need to write your own protocol. Whether you want to use protobufs or some other form of serialization, you might need to do that. The calling overhead, calling overloaded methods in Java or C is going to require that $1 or something similar to resolve those types. And they can require some very manual translation of like, well, I know what this object looks like in C and I know what I want it to look like in Dart, but I've got to like massage it a lot. And that can be a lot of like manually massaging those structures to look the way you want them to look. And lastly, although the new asset stuff solves some of this, the C linker behavior can be very, very, very confusing. For example, if you happen to be binding OpenCV and you happen to be exposing a method in a static thing, and then when you build the profile version, it just isn't there. This happens. And if you happen to need the magic LLM thing to make that work properly, this is it. This is even more confusing because LLM says it doesn't support retain, but it does. You just also have to make the visibility default. That'll prevent name mangling. That's the magic attribute to make your C function appear if it looks to Dart, if it looks to the application like you're not using it. But, there's a big but here. All of this stuff works great for asynchronous send and receive or synchronous send and receive. But what about a more complicated scenario? What about callbacks? So what do we mean by a callback? Well, in a lot of cases, we want to ask to be updated by a library on a regular basis. This is not a one-to-one, hey, give me some information, and later it comes back and says, yeah, here's your information. This is literally like, tell me every time a thing changes, like pub sub style. So how do we do that? Well, we can use method channels for this. There is a method on the native method channels called evoke method that will call into your method channel in the Dart side. Nice thing here, we don't have to worry about isolates. We don't have to worry about data serialization, but they are inherently asynchronous. So the major drawback here, though, is that you have to call invoke method from your main thread. You can't call it from any other thread. Won't allow it. It also will always execute on your root isolate. Can't change that. So if you don't want to do either of those things, you can't use this. Second way you can do it, with send and receive ports. This is an FFI way to perform callbacks and talk between an FFI library and Dart. It looks very similar if you've ever done isolate handling. The send and receive port is basically the same thing. In C, there is a send and receive ports that you can access from C. But they're very, very complicated to set up. If you've ever set them up in isolates, you know they're just as bad in C and C++. But you can call them from any thread, and they can jump into background isolates, no problem. But they're also inherently asynchronous, and they need to be used from C. The send port has a post C object, and that's the way you use it. I'm not going to go into too much detail on this one. If you want more detail on how to use send and receive ports, last year Rowan gave a really, really good talk about this, about their use of send and receive ports at Philips Research to do a lot of Bluetooth stuff. This is an excellent talk on this particular way to communicate between libraries. What about FFI methods? So there are some. There's a function called pointer from function where you can pass it a static Dart function and it will create a callback for you. But it's meant only for static functions. You can't use closures. You can't use member functions for this. However, there's also now native callable isolate local. These can be called, these can include closures, but they can only be called from the thread that created it. This is making sure that you're on the correct isolate for that to work. So again, you really can only do this if you have very tight control over what thread is going to call into your callback. But there's another one called native callable listener. These can be called, this started in Dart 3.1. These can be called from any thread. And these actually use send and receive ports behind the scenes. But as a result, they're async and they can't return data. Once it calls into the listener, the thread that called the listener continues on without waiting to see what the response is. So as a result, there's also native callable blocking. These can be called from any thread, but it blocks that thread waiting for a return value. With one problem. It doesn't exist yet. This is Dart issue number 54554. Hopefully this will come to pass very soon because it doesn't exist. But these are all for C. But for Objective-C delegates, so FFI Gen for Objective-C delegates does allow you to implement Objective-C protocols in Dart. You add the protocol to your FFI Gen YAML, and then it generates 3 implementation functions for you. So you want to implement the protocol, same thing, isolate local, you can do .implement. This is equivalent to isolate local. So if the iOS documentation says this will always be called on the main queue, or will always be called on a consistent queue, you can use isolate local. If it doesn't say that, you can't. Implement listener, this is the equivalent of native callable listener. So you can actually, this can be called from any thread, but it's asynchronous. Can't return data. Implement blocking. This can be called from any thread, but it blocks the calling thread waiting for the call to complete. This does exist. I don't know why this exists, but the native one doesn't, but this does exist and you can use it. And this is meant for, in iOS functions, when you have a completion handler and you need to call that completion handler synchronously. On JNI methods, JNI Gen also allows you to implement interfaces in Dart, which is great. You can use implement to implement your callback classes. And it tries to be smart. It uses send ports when it's necessary. If it detects that you're on the correct thread, it won't use them. But if it detects you're on the wrong thread, it will use send ports. However, this can only be used on interfaces. It can't be used on abstract classes. So a lot of Java and Android interfaces provide abstract classes that give you default implementations for essentially do-nothings, right? In this case, you need to use a proxy object where you create your own interface that then calls into the abstract class. This is what that looks like. It's a lot of boilerplate code. This is where GenAI is great. So what you do is you create an internal interface, callback interface, that has all of the different methods, and then just the proxy just calls into your callback for every single one of those. So we're going to look at a callback example. What we're going to do for that is we're going to play with Bluetooth. To do that, we're going to use one of these. This is a programmable LED light-up 20-sided die that is Bluetooth connected. And it tells me what I rolled. There's no really good reason for this. This thing's cool. But it also shows that essentially we're getting this data very, very quickly. We're using JNI to do all of this stuff. We're using FFI to do all of this. I love this thing. I gotta find the 20 side, there we go. So, how did we do that? So in our Objective-C FFI Gen YAML, you'll notice we have to create 2 outputs. One for Dart, one for Objective-C to do some of the binding code. you have to include that file manually in your Xcode project. But once you do that once, it's there all the time. And then we're listing out all of the protocols that we want to implement. In this case, the CB Central Manager and the CB Peripheral. The other thing is you have to give it an entry point. These change with every version of Xcode and every SDK. And they're really long. That ... that's like multiple directories. It's insane. And you have to kind of figure out where these are. Once you figure out where they are, I highly recommend figuring out like having a /applications like Xcode current symbolic link so that you can always have them in the same place. But yeah, this is a big pain in the butt. But to do the iOS callback code, what we're doing is you can see we're using implement as listener because I actually have no idea what queue the CB callbacks are going to call back on. And we're going to implement those methods, supplying implementations for all the methods that we want to listen to. And then we just create the CB Central Manager, allocate it, and init with delegate, and pass it our delegate. And that's it. On the JNI side, a little bit more complicated. All those $signs are internal classes. So we have that internal callback interface, the proxy, that we're going to call .implement, and pass it and create one. And we're going to fill in all of the callbacks that we want. In this case, on characteristic change, things like that. And then we just create it with our callback object and send it into actual JNI code. So given all of this stuff, which one of these methods should you use to create your plugin? So the first thing I want to impress upon people is method channels are kind of fine. They aren't as slow as people think. They don't have the CPU overhead that people seem to think they do. And if you have a bunch of method channel code that's already exists, you don't have to go rewrite it for performance reasons. It works great. But if you happen to need to bind a C library, using FFI and FFI Gen are going to give you better responsiveness. Not necessarily better performance, but definitely better responsiveness. If you're writing new bindings, you should probably start looking into FFI Gen and JNI Gen, partially because the Flutter and Dart teams want you to, partially because you'll get better performance, and partially because it's starting to get easier, especially with like @native and some of the new build hooks that we saw in the previous talk about an hour ago. And then the last thing is that if you need synchronous callbacks to respond to callbacks from native code, you absolutely, definitely should be using FFI Gen and JNI Gen to do that in the future, because it's really the only good way to make that happen. And that's all I have. Do I have any questions? There is a microphone right over there. And again, source code for all of this is up on my GitHub if you need to see better examples or go in more detail. Questions? Yeah. Yeah, I think you're good.
Okay, yeah. So let's say we have like 10 plugins.
Mm-hmm.
Do you recommend, and we are wrapping all of them, do you recommend each one be in its own plugin package, or do you recommend all of them be in one?
It depends on your use case. If you have 10 native libraries that you're wrapping, but they're all internal libraries that you're never going to distribute to anybody else, don't worry about it.
Yeah.
Don't you can package them if you want, but I wouldn't necessarily say you absolutely should put them in 10 different package pub packages. All the examples that I did here just use just use the app delegate and subscribe to the method channel that way. None of it's in package files, which is also the reason, by the way, that I had to use different FFI Gen and JNI Gen files, because I was generating for lots of different libraries. I know the burning question that everybody has, gamewithpixels.com. They're only $60 a die. Any other questions? All right, well, thank you very much, everybody. I think you're on time.